All right, so 11.2 is on rational functions. And in the book, it gives us this equation that y equals a polynomial divided by a polynomial. And essentially, we just want to remember that what that means is that we have variables in the denominator. Okay, we can also have variables in the numerator as well, but the important part is that there are also variables in the denominator. So our parent function, and by the way, these polynomials, they could also be monomials. It doesn't have to be a polynomial because, in fact, our parent function is y equals 1 divided by x. So we're going to go ahead and make a table of values. And let's just go from -3, -2, -1, 0, 1, 2, and 3. We're going to make more than we normally do. So if we plug in -3, then we get -1/3. If we plug in -2, then we get -1/2. Plug in -1, we just get -1. What happens when we plug in 0? We cannot divide by 0, so this is actually undefined. 1 divided by 1 is 1, 1 divided by 2 is 1/2, and 1 divided by 3 is 1/3. Okay? If we draw this, okay, let's zoom in a little bit so we can see a little bit better. Wherever my undefined was, I'm going to make that, I'm going to either use a highlighter where x is 0, or I'm going to use a dashed line. Since it's on the axis, I'm just going to use a highlighter. And then if we go to -3, then it's -1/3. And I'm just going to estimate the best I can. I know it's slightly less than 1/2. And then this is -1/2, 1, -1. We could plug in -1/2. Okay, if we have 1 divided by -1/2, then that is 1 times -2, which is -2. So that would go down here. And you can see that our lines start to curve. And then if we plug in 1, 1, 2, 1/2, 3, 1/3, then we're also going to get a curve that goes like this. Okay, this line right here, this is called an asymptote. It means that our graph cannot cross it. And it comes from wherever the denominator would equal 0. Okay, so it doesn't necessarily mean that x will be 0, but our denominator cannot be 0. So we can change this by changing the numerator or the denominator, and then we can also have a number outside of the fraction. Right here, let's say we added a number out here, then that will also shift. So let's do an example like that. So let's say we have y equals 1 over x plus 2, and then plus 1. Now we can also change the numerator, but for right now we're just going to do this. So let's go ahead and again, let's make our table of values. And then I always want to center our table of values around whatever would make that denominator 0. So I'm going to take our denominator over here, x plus 2, and I'm going to make it not equal 0. And if I add 2, then I know that x cannot equal 2. So I'm going to make that be the middle value, because when I plug in 2, I would get an undefined. And notice how I can ignore everything else and I only need to look at the denominator. Okay, so let me go 1, 0, 3, 4. We can put a 5th down here. So, and then we're going to do some math, and plug it in. So if we plug in 0 plus 2 is 2, 1 over 2 is 1/2, plus 1 is 1 1/2. If I plug in 1, then I get 1 plus 2 is 3, so 1/3 plus 1 is 1 1/3. 2 is undefined, we already said that. Oh, sorry, it should have been -2, because if we have x plus 2. My mistake. If we have x plus 2, it cannot be 0, and we subtract 2, not add 2. X cannot be -2. So let's change that. So then we go -3, -4, -1, 0, 1. My mistake. So we already plugged in 0, and so we got 1 1/2. And if we plug in 1, then we get 1 1/3. Okay. So if we plug in -1 plus that, then we get -1 plus 2 is 1. 1 divided by 1 is 1, plus 1, and we get 2. When we plug in -2, we said that's undefined. When we plug in -3, then we get -1 on the bottom. 1 divided by -1 is -1. Add 1, we get 0. If we plug in -4, then we get -2. -1/2 plus 1 is +1/2. All right, so now we can go ahead and draw this. You know what, actually. I'll just move that over. Okay. So my asymptote is going to be when x is -2. That's going to be my undefined. So I can use a dotted line or a highlighter. That's fine. And if we plug in -4, then we get 1/2. If we plug in -3, we get 0. If we plug in -2, it's undefined. Okay. If we plug in -1, then we get 2. If we plug in 0, we get 1 1/2. And plug in 1, we get 1 1/3. Okay, so see how these points, like they can't touch the asymptote, but they're gonna taper out like this. So I have another asymptote right here, and let's color code this so that you can see the blue asymptote comes from this value right here. So this side of my graph cannot cross either of them, and it'll go like that. Okay, so we ended up with a vertical asymptote when x was -2. And we get a horizontal asymptote when y is 1. Oops, sorry. Okay, so we can use that information to actually go ahead and graph the asymptotes first, or we can make the table of values first. Either way, this is how you graph rational functions. That's it for today. Let me know if you have any questions.